So what is the difference between a physical change and a chemical change in relation to chemistry? So a physical change is a change that does not change the chemical identity of the substance that's involved. Whereas a chemical change is a change that does change the chemical identity of the substance that's involved. So what does that actually mean? So as we said about a physical change, it doesn't change the substance chemically. So for instance, if I have this piece of paper and I tear the paper in half, I did not change the paper chemically into something else. I still have paper. I simply physically changed it by ripping it into two pieces. But if I wanted to change this chemically, if I wanted to do a chemical change on this piece of paper, one way that I could do that, one example, would simply be to light the paper on fire. If I lit this paper on fire, it would chemically change the paper to where I did not have paper anymore. So, just to recap, a physical change does not change the chemical identity of the substance that's involved, whereas a chemical change will change the chemical identity of the substance that's involved. So, let's look at a couple examples of this just to make sure that we understand the concept. I have 6 different examples of changes that could take place in the world around you. And what I'd like you to do is I'd like to invite you to pause the video and to think about what type of change each one of these is, if it's a physical change or if it's a chemical change. And I want you to think about why it would be either a physical or a chemical change. So I'll give you a second to pause the video. I'll assume that you've paused the video at this point, and what we'll do now is go through these examples quickly and go through what kind of change they are and why they are either a physical or a chemical change. So for the first one, ice melting. Ice melting is going to be a physical change. Now, it's going to be a physical change because you're not chemically changing the structure of the water. The water is simply changing from being in a solid ice cube-like state to a liquid water state. The substance that's involved, the ice, didn't change chemically. It's still water. It's water when it's in the form of ice, and it's water when it's in the form of liquid water. And so this is going to be a physical change. So, the next one, iron rusting. Whenever you see a piece of iron laying out and you see that orange coating on it, that's what's called rust. And so, iron rusting is going to be a chemical change. Now, it's going to be a chemical change because the actual chemical identity of what's involved is changing. The iron is combining with the oxygen in the air to form what's called iron oxide. And this is an example of a chemical change. The chemical structure or identity is actually changing. The next one here, dissolving sugar in water. Dissolving sugar in water is going to be an example of a physical change. This is going to be an example of a physical change because nothing about the substances chemically is changing. The water is still water and the sugar is still sugar. The sugar is simply being dissolved into the water, making what's called a solution. And so, this is going to be an example of a physical change. So this next one, breaking your pencil. If you get really frustrated with your homework and you break your pencil in half, that is going to be an example of a physical change. This is much like the paper scenario I showed you earlier, because you're not chemically changing your pencil into something different, you're simply breaking it in half and physically changing it by breaking it. So you still have a pencil, you've just simply physically changed it by breaking it into two pieces. So, the next one, a bomb exploding. This is going to be an example of a chemical change. This is an example of a chemical change because the substances inside the bomb before it explodes are going to be different than after the bomb explodes. So the substances involved at the beginning are being changed by the bomb actually exploding into something different, and hence it releases a whole lot of heat and also fire and explosion. And so that would be an example of a chemical change. The last one here might be a little bit more abstract or a little bit different, but cooking an egg is actually an example of a chemical change. Now, you might have thought that it's an example of a physical change because before you cook the egg and after you cook the egg, you still have an egg. And you might think that nothing has changed. But the true fact is that something has changed. Because whenever you cook the egg and apply heat to it by putting it in a pan or whatever you're going to do, the heat is going to chemically change the structure of the egg into its cooked form. And so, cooking an egg is going to be an example of a chemical change. So I hope this has helped with your understanding of physical and chemical changes in relation to chemistry. And you might ask yourself, well, why do I even really care? To understand physical and chemical changes will greatly help you in your study of chemistry because you're going to be able to understand when chemistry is actually happening and how things around you are actually changing. This can be very important in the chemistry lab as well as whenever you're simply working through examples out of your textbook or practice problems that your instructor might give you. If you have any questions about physical or chemical changes, please leave any comments or questions you might have below, and I'd be happy to get back with you as soon as I can. Thank you.